So this is the third video we're going to look at with regards to simple interest. It's the last skill that we need to cover. That is what happens when we don't know one of those three variables: principal, rate, or time. That is, we're given the interest instead. So finding values other than I. So we're going to use our knowledge of the simple interest formula and our algebra skills from year 8 to investigate the effect of unknown periods, interest rates, and principals. So as before, this rule is still going to be used. We still know how to change periods to years for time, because it has to be in years. We know to divide the percentage interest rate per annum by 100 to convert it to a decimal. So that formula has not changed and will not change the whole way through. So we're going to look at a couple of different examples today. This is our first one. How long would Jenny need to invest $5,000 to earn interest of $1,000 at 12% per annum? So it's a fairly brief question. Same as before, we look at the problem, see what we know. So pull out the highlighter, underline or highlight, we're going to invest $5,000, so that would be principal. We want to earn interest of $1,000, so that's I. Now these are two dollar amounts. Look for keywords to ensure that you get I and P the right way around. So when you invest or borrow money, that's your principal. Earn or pay interest, interest is the key word there, that's your I value. And we have 12% per annum, so that's our rate. So the one that's missing, we know I, we know P, we know our rate, we've converted it to a decimal, 0.12, we don't know time. So here's our challenge, we have to work out how to solve for T. So once again, we follow through, same as before, we write our formula, we substitute in the values we know. So we know I, let's have a look at that, I goes in here, P goes in here, so we're substituting in, and the 12% there, the decimal 0.12 goes in there. And remember, each of those variables, we're multiplying together. So we evaluate that part first. That means to calculate or work out that part of the sum. 5,000 times 0.12 is 6,000. Okay, one way to do that in your head. 5 times 12 is 60. That's the decimal to 0.6. And then we're going to shift the decimal place 3 places that way, giving us 600. That means 600 times T. So our algebra skills from last year were that we balance that equation by moving it to the other side by dividing. That's the opposite operation, or the inverse operation of the 600. So T equals 1,000 divided by 6,000, like so. Okay, now we can calculate that as a decimal. It's about 1.67, but that is rounded. That's not necessarily a good thing. So we try to avoid rounding if we don't have to. So let's round it off. So that's probably not the best answer. Most calculators will convert that to a decimal or a fraction. But you should recognize that 0.6 recurring is 2/3. So that's 1 2/3 years. So how many months are there in a year? It's 12. So 1/3 of 12 months equals 4. So we have 2/3, so that's 8 months. So what we actually have there is 1 year and 8 months. And that's a better answer than 1.67 anyway. It makes more sense to most people. So there's our answer for the word problem. It would take Jenny 1 year and 8 months to earn $1,000 interest. So on our think board, there's our problem in the middle. Same as before, we're going to identify that information. So invest $5,000, interest $1,000, 12% per annum. So they're the variables we know. We're just going to highlight those or label them here. I equals 1,000, P equals 5,000, R is 0.12 as a decimal, and T is the unknown. How are we going to solve it? What's our strategy? It's going to be using the simple interest formula, I equals PRT. Exactly the same as before. We write our formula, our do part, substitute, and solve as before. Again, it's 1 2/3 years, or 1 year, 8 months. How do we check that answer? So the easiest way over here, this is our check for reasonableness. 1 2/3 years is close to 2 years. It's a little bit shorter than 2 years, but that's good enough for a quick check to see if it's close to the right answer. Our interest rate there, 0.12, is close to 0.1. It's a nice easy number to work with. So using the formula I equals PRT, we're just going to use those estimates of what we found and see if we actually do get the interest of $1,000 up here. So we substitute those in. 5,000 times 0.1 times 2. So divide by 10 is the same as multiplying by 0.1. So this bit here is the same as dividing by 10. Which gets rid of one of those zeros. So that's 500 times 2, which we can do in the head is $1,000, which matches that answer. So it seems that our answer is reasonable. So that's our first example. Let's look at another example. Same strategy as before, highlight the information we need to know. So we want to earn $300 of interest. We invest $800 and have a period of 100 weeks. So this is actually a bit trickier. This is one of the more challenging questions that you'll be needing to answer. And we want to know what is the interest rate. So let's summarize that information. So I is $300, earning $300 of interest gives us I. Investment means P for principal, so that's $800. Our interest rate we don't know, put a question mark. And our period of time is 100 weeks. We know from last lesson that to convert weeks to years, there's 52 weeks in a year, we divide by 52. So 100 divided by 52 is approximately 1.923 years. That decimal actually goes on to a number of decimal places on your calculator. This answer here is not the best one, okay, because we've rounded it. This is the answer we want to use. So our calculators can work very efficiently with fractions. So we're going to leave it in fraction form, and that way we only round once at the end of our question. So here's our formula then. I equals PRT. I is 300. We're going to substitute those numbers in. So let's just indicate where they go. I goes in here. P, 800, goes in here. R we don't know, so that's what we're trying to find. And this fraction is our time, not the 1.923. So we evaluate these two bits. So we can rearrange these. One of the laws you learn about in grade 7 is called commutative law. And that says this is the same as this. The order in which we multiply three numbers, so it's actually the associative law I should say, the order in which we multiply three numbers is not that important, okay, because the operations are equivalent. So we can do the same thing here. 800 times this, do it on your calculator, leave it in fraction form. 300 equals that times that is 20,000 over 13. Now it looks like a bit of a messy fraction, but it's much neater than the decimal answer that it would come up with. That's multiplied by R. As we learned last time, to isolate or get the R as our unknown, we need to use the inverse operation. So that's multiplying by that fraction. We need to divide by that fraction over here. So 300 divided by that fraction, like so, which equals R. And that comes to 0.195. Now, that's a fairly neat fraction. It actually comes to an exact 3 decimal place value. If we use one of these rounded numbers at some point, this would not be so neat and tidy. So that's one of the benefits of staying with fractions for as long as possible. Now, interest rate, that's what R represents, is a percentage per annum. That's what we're told right at the start of the slides. So we multiply that by 100, and we get 19.5% per annum, which is quite a significant interest rate. So there's our answer. On our think board, let's think about that again. Same as before, highlight our critical information we want to invest. That's my highlighter. So we want to invest $5,000, earn interest of $1,000, and it's 12%. So we want to know how long. Incorrect question there, so let's just ignore that. As before, we pull out the correct values, leave it as fraction, remember, not that decimal. So let's put a line through that so we remember not to do that. Our strategy, simple interest formula, and then we substitute in and solve, working with fractions as much as possible. So let's check how we can check our reasonableness of the solution. So this time we're going to take our 19.5% and these values here and check that it gives us about $300. So the first thing we're going to do, 100 weeks is just under 2 years as evidenced by that decimal number. So we're going to round it to 2 years to make that calculation a bit easier to do in our head. 0.195 is close to 0.2. 0.2 is a fifth. So if you divide by 5, it makes it a nice easy calculation as well. And our principal, we could leave it as 800, but I'm going to round it to 1,000 as well. So we're going to use these three numbers and quickly check, does that get me a number close to 300? So we've rounded that one up, higher than it should have been. This one's been rounded up, and this one's been rounded up. So when you use three numbers, those three numbers there, our interest that we're going to calculate with them should be more than $300 because we've made all the numbers bigger. So we substitute into our formula. 1,000 times 0.2 is 200. We shift the decimal place, or we divide by 5. So we multiply that by 2, we get 400. Now obviously that's much bigger than $300, but we did make some fairly big rounding numbers, particularly this principal here, $200 is a quarter, again, as big as what we started with. So it's still reasonable, it's close, but not really close. So from here you should know how to use your algebra skills to find one of the other unknowns.